Hello and welcome. We're going to hear about Puppet and Python by Daniel Sleuters, so please give a warm welcome.
Thanks. There we go. Perfect, thank you. So Puppet in Python, it's a bit of a controversial talk for a lot of people. Puppet being Ruby, Python being Python, people complaining that I'm combining two things that they love and hate in a single talk. So I'm Daniele Sleuters. My name is confusing to most people because they think I'm female because of the E at the end. Guess what? I'm not. Most people know me as Danny because of that on the internet. I have a habit of trying to automate just about everything that I run into. Like if I have to do something twice, I'll spend a few hours to automate it just to make sure that I don't have to do it thrice. I ramble about diversity in tech. It's a subject that's sort of near and dear within, like, close to my heart. As far as Puppet goes, I've got about 5 years of Puppet under my belt. I started on Puppet 0.24, like back in the, I think 2008, 2009 somewhere, on Home Labs. It moved on to like my job. It became part of my job. I became a contributor. As far as Python and Puppet goes, the most notable project I've worked on is PyPuppetDB, which is a Python library to talk to the PuppetDB API. PuppetDB Stencil, which allows you to combine the PuppetDB API and Jinja to template out resources for those cases that you don't want Puppet or where Puppet is actually too slow. And Puppet Board, which is an OPSI-focused dashboard on top of PuppetDB. I'm also the unofficial maintainer of Puppet Labs apt, the official app module. I'm the unofficial maintainer, together with Morgan Haskell from Puppet Labs module team, who's a fantastic engineer to work with. And at last PuppetConf, we launched a project which we're calling Puppet Community, where we're trying to get a lot of people to write tools and write their modules, but give them in a shared community namespace so that anyone and everyone can contribute to them, so that once you get tired of maintaining a module or you have no longer a need to maintain that module, other people in the community can take over without, you know, getting into the whole namespace collision hassle, like who hands over, who has which credentials and so on. I think we need a few disclaimers. This is not a data science talk. Compared to a lot of the other talks at this conference, I am not going to show you how to combine Puppet and Pandas to create scatter plots of I have no idea what. And this is also not a web dev talk. I won't be telling you that Puppet is this fantastic web framework that you can build stuff in, because it really isn't. This is about ops and automation in a lot of ways. The way I like to think about ops and automation, and why it's sort of near and dear to my heart, is they give me an API and I'll automate the world. Essentially, if I have systems that I can talk to, that I can push and move data through, I should be able to create something that can just make decisions in and of itself. I can combine it, I can give people insight into what's happening on their infrastructure, and hopefully at some point get semi-sentient infrastructure. The point why I really try and work on this is because in about 10 years from now, I like to be there. I like to be on a beach with a drink, you know, just peace, calm, and serenity, and just this slight little notification in this neural implant that projects this one thing on my cornea that goes, the world is running. Everything is fine. The world is automated. Things scale automatically, and you have nothing to think or worry about. Turns out that would be a great picture, because more or less my day now looks sort of like this. We have lots of things that we need to maintain, lots of things that are in fire, and you feel more like you're a sort of firefighter. So if you can end up combining systems that can hopefully prevent the fires or fight the fires for you, you can do a lot of fun stuff. When you start out with Puppet, you sort of go through the 5 stages of Puppet. So you start with like the installation issues, right? It's like, god damn it, I can't get this thing to install. How do you spin up the master? Okay, fine, I have a master and an agent now. Can those two actually talk? Certificate errors, what the hell is going on? But after a bit, you get it going, and you're sort of like, well, this is actually pretty neat. You write your first resource, you write your first, you know, package file service thing, it manages to install a service, it manages to do stuff for you. And you're like, okay, I can work with this. So you grow your infrastructure on it, and after a while, it's like, okay, I've written my first module, because you actually ran into a component either in-house or external that no one has actually written a decent module for. So you've written the module, you've done your work, you've written tests for it, obviously, and you've uploaded it to the Forge, allowing other people to use it. So once you've done that, you start going a bit deeper. It's like, okay, I've written a module, I've written 2 modules. Can I make it dance? And at that point, you often have to go in a lot deeper in Puppet. This is the point where you generally tend to go like, okay, I need to write a type and a provider, which unfortunately we do in Ruby. Or you actually need to patch Puppet, at which point this realization hits. It's actually Ruby. And one of the most freaky parts as a Python programmer when you look at Ruby code is that the thing returns things without there ever being a return statement. It returns the last statement that you've executed and like the value of that. But the problem is, once you go and think about APIs, anything can really be an API. Like nowadays, when you talk about APIs, a lot of people think, okay, that's HTTP, REST endpoints, and shoveling JSON around, which in an ideal world would be the case. But when we're talking about like, you know, systems automation, it's not an ideal world, like don't by a long shot. You have to work with the tools that you have, and a lot of those are at times CLI tools. So you get to do fairly fun and interesting things, especially if you have like a Puppet infrastructure but you're mostly a Python shop. There are ways that you can bridge it. So one of the sort of semi-clever things that you can do is like if you want to know what kind of settings are available to your in Puppet but from Python, you can actually ask Puppet. You go puppet config print and Puppet tells you, okay, these are all my settings, the one that you have defined in puppet.conf and my built-in ones. Now this is normally like a list of key equals value pairs, so it's super easy to parse with config parser, except that config parser gets very, very mad if it doesn't have a section header. So you do the little hack where you have the section header and then like the interpolation marker, and you call out to Puppet, pass it config print as arguments, and then you can actually read it in, and you end up with this dictionary or of settings if you want to, which has just like every key value pair that you need. And with the newer APIs, like this is Python 3.2 and upwards, like I ignore Python 2 in this talk. You can actually do things like, you know, from the setting or from the section Puppet, give me the Boolean autoflush. And newer versions of config parser actually know that, you know, the string true maps to the Python Boolean true, the string false maps to the Python Boolean false. So we'll actually get sensible information back from the system. One of the reasons I've done this before is mostly because I wanted to check whether Puppet was configured in the state that I expected it to be before it can actually run. So you can check whether it's pointing at the right servers, has the right certificates, has certain settings enabled like the future parser or not. This essentially allows you to wrap around that in Python, a language that you're familiar with, instead of having to potentially write a Puppet application or a Puppet face that hooks into the Puppet internals. You can go either way. But depending on what your tooling is, what your preferred language is, and what you're most familiar with, this is a very easy way to go. It's also nicely testable, which a lot of Puppet code is sort of not. The other fairly nice thing that you can do revolves around factor. So factor is a component in the Puppet stack that tells you things about your machine. Once you run factor, it starts to discover things like what's my operating system, what's the hardware that I run on, that all kinds of things, which Ruby version am I running on, platform hardware, so on and so on and so on. Something that a lot of people, for whatever reason, have missed is that factor since version 1.6, so like 2011 somewhere, has had the option to output both JSON and YAML instead of just the weird Ruby-ish syntax of like key and then the fat hash rocket thing and the values. Someone has actually written a library to parse that, but instead you can just call out with the JSON argument, which gives you a JSON string, which you simply JSON.loads. At which point you get a fact set that has all the information about your machine. Now in recent versions of factor, it stopped being significantly stupid and started outputting actual types for the information that you had. So previously all facts, whether they made sense as a boolean or not, or even if they made sense as a list or a dict, they were strings because factor had no concept of types. This got fixed somewhere along the lines of Puppet or factor 1.7, and in 2.0 they flipped the bit by default. So now for a lot of the values that you get, you don't get the string false when you get the JSON output. You actually get like the JSON false, which Python correctly maps to the actual false in the Python language. Same goes if you, for example, pull up OS. This used to be like a super garbled thing that you'd have to manually parse in some kind of way. Nowadays, it's just actually a JSON object which gets shoved in there, which JSON.loads know, and you can just use and manipulate as it is. One of the most important takeaways that I got from like trying to use the Puppet command line, using the factor command line, using even mcollective command line, and wrapping Python around it, is that it is super helpful if your CLI tools has a machine-friendly output format. In the case of like Puppet config print, the format in and of itself is so easily parsed that you really don't need like an additional JSON switch. That would have helped for the typing information in some places, but you can sort of deal with that with the tools that Python already gives you. Factor is another example. You add just --JSON and you're good to go. But there's plenty of CLI tools that output in some kind of like table format with nice headers and everything, which is super amazing for humans. But when you actually want that information and ingest it into the next system, essentially sort of what Unix pipes do. You take a thing, you pipe it into the next one, and you go and you go and you go. The fact that the original source is something that comes from Puppet doesn't really matter in this case. Once you have a format that you can just take and shove and manipulate in any language, which JSON is particularly good for, it makes things a hell of a lot easier. So once we skip to the from the CLI, we can actually do things with Puppet and Python. So for those who don't know, Puppet has had something which we're calling the PuppetDB for a while now. Like it stores all kinds of information about your infrastructure. Whenever a Puppet node checks in, you'll get a host entry into PuppetDB. You'll get the complete fact set of that machine uploaded into PuppetDB. Any kind of exported resources is available, and the full catalog is available too. So you can actually ask PuppetDB like, hey, the last catalog that was compiled for this machine, what does it look like? Which resources did it contain? Which edges does the graph have? So a while ago I wrote a little library in Python which leverages kinesis requests, which essentially gives you a programmatic access to the API. The API in PuppetDB is a bit so-so. Like they did their best to try and design something, but they clearly haven't done it before. So you have to work around a few weird things in the API, which is why I wrote the wrapper instead of just going raw requests. In this case, you just call connect on the thing. You can pass in a bunch of arguments like where it actually is. It can handle certificate authentication for you, so you can deal with client certificates and a whole bunch of other things. And essentially, like, you know, I want to tell me all the nodes, and nodes have different attributes like its hostname, when it checked in, when we uploaded facts for the last time, whether the last run for this node was successful or not, and which changes it had. So you get that back, and based on that same hostname, we can query other things. We can query for the full fact set if we want. Instead of calling fact, you can call facts, and you get the complete thing back. You can get a single fact by calling fact and the fact that you want. You can get the catalog back, you can get a full inventory back for your machine. This is essentially what I later used to power a Puppet board, but you can do a whole bunch of things with it. One of the main tricks that I've pulled off with this is actually generating DNS data based on the host entries that you get. You can also have machines do things like add additional exported resources. They go like, okay, you know, I'm this machine, hostname ABC, but I'm also providing services under these 5-6 different host names. You export those through exported resources. They end up in PuppetDB, and you can query for them and generate DNS zone files or whatever else you kind of need to do. Now, if you actually have to generate different files, like you start templating out resources, essentially we're starting to rebuild Puppet in Python. So we combine those two with in something that we call PuppetDB Stencil. It's essentially a combination of PyPuppetDB and Jinja. Jinja is a very nice templating language that the guys from Puku developed, and you can actually use it the same thing. So what we're telling you here is, given a resource type, file, package, service, nagios underscore host, nagios underscore service, it was geared towards nagios essentially. It's like, grab all those resources for me, given a name of templates, find the one that matches, and if so, just pass the whole list of resources that we have to the template. And in that template, you can do essentially whatever you could do in an ERB template in Puppet or a embedded Puppet template that we now have available in Puppet 4. So you can loop over the resources and create anything that you want. So essentially, we just replicated what Puppet can do template-wise, but we're directly pulling information from PuppetDB, which has the sort of neat advantage that there are machines in your network where you want configuration changes, especially topology changes in your network, to propagate to as fast as possible. Now, if you're simply relying on exported resources in Puppet, it means that you need to continuously run Puppet on those machines, like essentially every 2 or 3 minutes, so that it'll talk to PuppetDB, collect the exported resources, template them out for you, and write the file to disk. This gets expensive, especially if you have bigger catalogs, or if you have machines where you're not actually comfortable running Puppet on, because, you know, Puppet can be used to do great good and also fantastic evil. So the idea with this is you can use this to talk to PuppetDB. Like every time a machine checks in, it'll upload all its data into PuppetDB. You can simply have like a cron or anything else that you want, a periodic task in any form, that just talks to PuppetDB. It goes like, hey, give me all the resources. And then you template out your, I don't know, your Apache vhost configuration for your load balancers, or your DNS data, or whatever. And you just let it reload in and of itself. Which means that you can create a system where changes to your topology that PuppetDB is aware of can propagate to those machines that matter within seconds instead of minutes, or needing to wait on the next Puppet run, which traditionally happens every half an hour. So the sort of other thing that we did was called Puppet Board. Once upon a time, we had something called the Puppet Dashboard, which was a separate data store. It was a MySQL backend thing, which used to also be used for the exported resources until we actually had PuppetDB. And you could use that to do a whole bunch of things, but it was a separate report storage, a separate database. You ended up having 2 full copies of the same data, one stored in PuppetDB very efficiently, and one stored in the backend of the Puppet Dashboard in a fairly terrible manner. And so, based on the creation of PyPuppetDB and, well, PuppetDB itself, we created a dashboard on top of it, which essentially just queries PuppetDB for information. This also makes this dashboard sort of read-only, which is a neat additional trick. People can actually look at your infrastructure, but they can't blow it up by clicking on buttons and deleting nodes and things like that. But all it does is talk to the API. You can do a lot more of those things with the API. Like I've done things that allow you to get notifications on your phone when there's a catalog compilation error, or not a catalog compilation error, but when a node uploads a failed report into PuppetDB, you can actually get pinged and it goes like, okay, hey, we have a problem here. You can tie it together with as much different things as you want. And because you have an API to work with, it doesn't have to be Ruby. It doesn't have to be scary. You can actually use a tool that you like, a language that you like, a language that you're familiar with, that you know how to test, that you know how to do things with. Like Puppet Board, for example, is just Flask, Jinja, and essentially PyPuppetDB, so requests. That's all it took. And some CSS and stuff. One of the other things that I've been looking into is once you start extending Puppet, like the main thing that you often want to do is a type and a provider. So in Puppet we have the definition between native types or types, like file, package, and service, the things that are shipped with Puppet, and defined types, things like, you know, I don't know, apt : source, which essentially is just like a little, it looks like a class, but it's not a class because you can use it multiple times. You can pass it in parameters and it calls out to other resources, essentially creating, you know, a little piece of code that you can reuse. But often, especially when it gets more complicated, or when you want to talk to an actual API, like let's say the Docker host, or you want to talk to an F5 load balancer, you need to create a sort of native type, because you don't want to be doing this with exec resources in Puppet that have like, okay, only execute if this thing and if I get notified by the other thing and so on. It becomes messy. So you get to types and providers, and types and providers in Puppet are messy in and of itself. They're not very well defined. But the idea is you define a type, which is just like a defined type, but defined in Ruby. You tell it the parameters that it takes, the attributes and the properties that it has. And on the other side, you implement the provider. Now the idea is that you have a super strict separation there. You have the type definition and you have the provider. Because both are in Ruby, people started doing this. You can actually call things from the type on the provider and from the provider on the type, which is messy. And it sort of messes with that system. But one of the cool things with Puppet 4 is that you'll actually be able to define the types in the Puppet DSL itself. So you won't actually have to drop to Ruby anymore. And since we get that very straight separation, one of the things I've been working on is creating a sort of shim provider backend which can load external providers. So it doesn't have to be Ruby, it can be Python, it can be Go, it can be Perl for all I care. What we're essentially trying to define is a data format between the provider, what it gets, and the external thing that it ends up calling. So you end up doing the same thing. You end up shoving JSON around. For me, it's because I want to do stuff in Python. For other people, it's because I want to do things in different languages. But the point that I'm trying to make here is that you can extend this in all kinds of different ways. One of the other sort of painful things with Puppet is integration tests. Puppet has had a bit of a weird history when testing goes. We have had RSpec Puppet, which allows you to do unit tests on the catalog itself, but it doesn't allow you to do integration tests. So for a while we had RSpec System, but no one really liked it, and it kind of died. Puppet Labs created their own system, which they call Beaker, which they use internally, and someone created an RSpec bridge, which is called Beaker RSpec. But a lot of things that Beaker tries to do is it tries to do too much. It wants to spin up machines for you, it wants to provision Puppet for you, it wants to run tests for you. It's like, it's a lot of things together, and for a lot of people, it's fairly daunting. Also, I don't like writing tests in RSpec. Like, I really don't enjoy doing it. And I've been thinking for a while about creating a PyTest plugin, which would allow you to do just that, because essentially, we don't need to talk to Puppet for integration tests. We just need Puppet to run on a machine and validate the output. I don't actually need to know what the catalog looks like that it built. I just want to know, like, okay, you've applied it, you did it successfully. Does it actually do what I expected you to do? Turns out someone actually beat me to the punch. I found the project last night when I was Googling for an example on how to actually do this, and it's called Test Infra. It leverages PyTest and PyTest XDist, so you can actually run test runs in parallel. And all you essentially end up doing is, like, you know, assert this file exists, assert that it is a link, assert that this service is running, in very simple PyTest style, and you're sort of done. You can write your integration test for your full infrastructure in Python. And it doesn't work with just Puppet. You can use it together with Ansible or SaltStack or, God forbid, Chef. One of the other things that's happening, which could be really interesting, is that Puppet's moving to the JVM. It's the Puppet server, the new one, is actually written in Clojure. It leverages JRuby to load the current code base sort of into the JVM and work from there. And little by little, it's being pulled apart. But because it's moving to the JVM, we can start doing things with Jython. We can actually load Jython in there, and in the same way extend Puppet through Python server-side by using the JVM. So with that, I'm sort of done with like all the crazy things that you can do to extend Puppet with Python. I'm not necessarily saying it's a good idea. There's definitely a few things in there that are not a good idea. But, you know, you can take it as far as you want to go. So does anyone have any questions? Nope. Oh, there we go.
Actually, I'm more intrigued. What's the difference between Chef and Puppet, and why do you don't like Chef that much?
Right. So, my issue with Chef is sort of my issue with Ruby. I don't like the language, and Chef exposes Ruby to a whole lot more. Like, essentially, when you're writing cookbooks in Chef, you're sort of writing Ruby, which also means that you can do stuff through Chef, like hook in at different levels, overwrite parts of the catalog, go back in. You get a lot of different layers where people can come in and mess with your cookbook and mess with the end result, which makes Chef code, at least to me, significantly more difficult to reason about than the Puppet DSL, because it doesn't actually allow you to do that.
So you just said that some of your suggestions were bad. Which ones were the ones that we shouldn't actually do?
So the one about hooking Jython into the JVM might be a bit iffy. Like, I have no idea what's possible there, so you might want to be slightly careful there. The other one, which is still very much a work in progress, is like figuring out the protocol between types providers and like calling external stuff through Python. So though we have an idea there, and I'm kind of hoping to launch it somewhere this summer or during at least PuppyConf, it's probably going to take a while before it sort of stabilizes. So it's a cool proof of concept, but I'd like to actually be able to turn this into like a Puppet, what we call an ARM in like the Puppet community, where it's an actual like a formal proposal that gets accepted into the system, and then we have like a really well-defined protocol that anyone can use at that point.
I guess there's no more questions. So
No.
thank you, Daniela.